I would go to CISOs and I would say, hey, how many models do you have in your organization? And on average, they would answer 80. And then we would go scan. And on average, we would find 1,700. Data scientists, the first thing they do when they download a model is load it up, check it out, start playing with it, seeing if it works. And so if you're a threat actor and you hid some ransomware in there, it doesn't matter if they have any technical controls in there or not. Without any kind of proper tracking for where these models are, it's kind of free reign right now. We're not very many years away from not being able to secure anything without the capability of securing artificial intelligence. So I think the way that you soon will secure networks, the way that you'll secure endpoints, the way that you'll secure accounts and entities and identities is going to be by securing artificial intelligence.
Welcome to AI in the Real World. I'm Sid, a partner at Foundation Capital, and I'll be your host today. I'm joined by my good friend, Chris Sestito, also known as Tito. Tito is the co-founder and CEO of HiddenLayer, a cybersecurity platform purpose-built for AI systems. His journey into AI security began at Cylance, where he led the response to one of the first real-world AI attacks. In our conversation, Tito shares his insights into the evolving AI threat landscape, from shadow AI to the growing arsenal of strategies that target generative models. He explains why data poisoning is one of the most urgent threats facing humanity and why safeguarding AI will define the future of cybersecurity. Here's Tito. Hey, Tito. Welcome to AI in the Real World.
Hey, Sid. Thanks for having me, man. Excited to be here in a chat.
So we have a whole bunch of things that we want to talk about today, but let's maybe start with a little bit about your background. And today, obviously, you're the CEO and co-founder of HiddenLayer. But before this, before Qualys, you were at Cylance, where you were running the threat research team from an AI perspective. And back in 2019, you experienced one of the first major adversarial AI attacks in the wild. Maybe talk us through that incident, how you discovered it, how did you respond, and why did that interest you to go and start this company?
Yeah, thank you. And it really was sort of the kind of inflection point and the catalyst ultimately for HiddenLayer as a company. So again, Cylance was really started around 2012, a company that was using artificial intelligence really to take the next step in antivirus. And now it's what all the endpoint security solutions do. But essentially, antivirus was really just lists of bad things for a very long time, and then it would just check the machine to see if anything was on those lists. And then threat actors started catching on to the fact that they didn't have to make any sort of new and hyper sophisticated attacks. They just had to create new attacks faster, so they weren't on those lists. And then that led to the need for something like artificial intelligence to be able to see something it had never seen before, and then make that delineation between good and bad artifacts at that time. And so that's what we were doing. We had at the time it was a dual feed neural network, but this is pre Gen AI. We had a neural network inside of our Windows product that we were using to do exactly that, identify malicious threats. It was very, very efficient. It was very, very accurate. But then what ended up happening, as you mentioned in 2019, some threat actors actually just through a free trial of our product ended up interacting with that model in the exact same way we wanted our customers to. But what they were doing is they were basically submitting adversarial samples to it and seeing how it reacted to them. And then with that pattern over and over again, they were able to commit what we know today as a surrogate attack. There wasn't really a name for it then. But ultimately that meant they were retraining the model offline. So they had an identical copy. And then offline, they were able to do things like, attack it, send bypasses to it, see what was going to work. And then they would know that would work online. And they would bring it online and conduct it against our customers. And so it was, it was a branch of inference attack for like inference time during a model. It was one of the first cases of that in the wild. And so myself and my co-founders, Tanner and Jim, we were kind of charged with the response effort. We had to go, ultimately sort of stop the bleeding on that attack. It was highly consequential. It was like 95% of our revenue came through that model. And so, we just said, hey, we gotta react to this. And then it was really during that process, we learned how incredibly vulnerable AI is. And ultimately that this was for a problem for many more than just Cylance. It was a problem it was a bigger problem than for cybersecurity. It was a problem for anybody who was deploying artificial intelligence models or systems into production systems and allowing either the public or their customers to interact with them. And so that's kind of what got us here today.
And why did you post that? Why didn't you start HiddenLayer immediately after? Why did you go to Qualys, kind of work in an equivalent role at another big cybersecurity company? What was the reason behind that?
Yeah, so back in 2019, we were kind of looking at the market and we were like, look, we know how important this technology is going to be, but we knew we needed to scale alongside artificial intelligence. So we knew it was pretty early, and we said, hey, let's continue developing this on nights and weekends. Let's continue understanding this. We knew the AI boom was coming. We didn't know if it was in 1 year or 10 years, but we knew it was coming. So then I followed one of our CROs over to Agari, where we were building artificial intelligence models for like identifying phishing in emails, and brand protection as well. And then that there was an acquisition there, so I went over to Qualys, and Qualys was cool because they had a treasure trove of vulnerability data. They've been collecting more vulnerability data than anybody for a couple decades. So, and they never had a data science team. So I was like, all right, I'll go start that, and we can start showing them how to predict things and use some of that awesome data set. And then, early 22, Jim Tanner and I kind of looked at each other and said, we're seeing signs. We think there's going to be adoption. We were seeing other areas. It primarily then was like medical, the medical field starting to leverage more AI for prediction of things like how drugs were going to be impacting populations, and different, whether it was drug trials or whether it was on the like side from like how people were going to be able to use them and afford them, and all kinds of predictions in those cases. We started seeing it more in like HR. Models were starting to be used to do things like predict which employees are unhappy, or there was a whole bunch more. A good friend of mine who's now an advisor of the company, and he was my professor at UT, wrote a book on HR use cases and artificial intelligence. And so we started seeing it all crop up. We knew a little bit of what was coming down the pipe from OpenAI with ChatGPT, and we said, we think now's the time. So if we did it back in 2019, we would have had to stay alive an extra couple of years, which would have been difficult. But so ultimately, that was it was a practical decision. It was really more about how do we, timing is going to be really important. I'll add that it was the hardest thing we've ever had to do. I mean, we really wanted to start that company and really wanted to move forward. But ultimately we got to do what's right if we're going to build an organization and make sure it's healthy at the time, that we're going to be able to take off.
Most folks in the cyber world think of you as kind of being a company that was started in 2023 after ChatGPT was launched, because they remember the RSA sandbox win that you
Right.
had, and being on the the front stage and the main stage at the largest cyber conference. But the truth is that you, Jim, and Tanner started the company at the beginning of 2022. And I remember seeing the three of you in Austin, spending a bunch of time as you were kind of coming up with this idea. And that was 6 months before ChatGPT had even launched. Like, this was well before the craze that we had. How did that change your thinking? Obviously you start the company, you get started, and then later that year, at the end of 2022, OpenAI launches ChatGPT, and that pushes generative AI to the mainstream. Did that change how you thought about AI security?
It most certainly did in a couple of ways. And so, first of all, it's cool talking with somebody who saw us, ahead of that too. I mean, you kind of saw me at my earliest in the founder days when I didn't know how to spell VC, and then all the way up to now when we're trying to figure out, how to continue into a growth stage. So, that's really cool to be able to chat with you about all this. But yeah, I think really the biggest catalyst for us, or the biggest catalyst that was offered by sort of the Gen AI revolution, and in particular ChatGPT, was ultimately that now it became a lot easier to have these conversations. I think all the way back to 2019, when we were talking to CISOs about this, we had to start the conversation out with things like, hey, take for granted that you're going to have to secure artificial intelligence. What does that mean to you? Help me walk through that. And it was very high level. It was very, like, to them, it's like a future conversation. And this is usually a role that had 30 other things to think about in terms of priorities. And so it was different. And we still did it. We still wanted to get information. That's what ended up helping us choose a platform opportunity to move forward. We still got good information. But then after ChatGPT, CISOs start really thinking about this in terms of what they have to do. If you go, as soon as that became a reality, about a quarter afterwards, if you went to a CISO event, the top three things they were talking about is, how do I secure my AI? How do I use AI to do my job more efficiently? And then how are the bad guys using AI in order to attack me? And so it really bubbled up quick. Nobody was able to say, I don't understand anymore. They were really sort of forced to face and by the way, that's not a Cisco or CISO exclusive issue. That's an every executive issue in terms of really an industry agnostic issue in terms of how you're going to leverage artificial intelligence. And there isn't a board on the planet trying to figure out their AI strategy if they don't already have one. And so but for CISOs in particular, our sort of buying profile, it gave us much it kind of rose the floor for that conversation. And so, we were able to start to have conversations with that were a little bit more kind of like step 3 or 4 versus kind of the beginning of like, here's what artificial intelligence is. Here, like, at the beginning, we were introducing security teams to their data science teams. They'd never met in a lot of cases. And so, now it became a much better path forward. But the other sort of way I'll answer the question is it drew attention to a lot of traditional machine learning. So, even today, there's a lot more traditional machine learning models, or what we generally call predictive models. I got to be careful with the word generally there. What we usually call predictive models is that's still a lot more of what we see in production systems today. We're starting to see a lot of Gen AI use cases emerge, and they're hitting production systems. And there's 3 or 4 use cases that are pretty broadly accepted today. But when you're talking about securing artificial intelligence at an organization, you're still looking at a lot of tree-based models. You're still looking at a lot of neural networks. You're even looking at simple linear models in a lot of cases that are all still extremely vulnerable. So it even though it was Gen AI and people aren't really sure if they're plugging LLMs into production systems, back in the 23, early 24 timeframe, it still called a lot of attention to the vulnerabilities that existed now in their stack with the other models. So it became easier to have that conversation. And then I'll fast forward all the way to today, where most either have something in production on the Gen AI side, or they've got plans to deploy it in the very near future. And in most enterprise organizations, there's a lot of places in which that's the case. But yeah, I would just say it made the conversation a lot easier to have.
Let's move to the AI threat landscape. You touched a little bit on this, but I want to go back to the pure fundamentals,
Mhm.
which is what makes these AI systems uniquely vulnerable compared to just traditional software. Why can't we just use the existing cybersecurity toolkit that we have today?
Yeah, it's a great question because it really is motivationally a lot of the same things that we're securing against. It's just really a new uh, segment of the threat landscape. And I'll answer it in 2 ways. I'm going to answer the supply chain side of that, and I'm going to answer the runtime side of that. So on the supply chain side of that, now an artificial intelligence model, everybody's coming up with their own proprietary frameworks for AI. And so you have like, the ones that most organizations are using, which is like Keras, TensorFlow, some of these open source libraries developed by Google, developed by Meta. And then you have all these proprietary frameworks now starting to pop up. Like Microsoft has Onyx, NVIDIA has Nemo. There's roughly probably 50. There's probably way more than that, but in terms of like that are leveraged widely. And so if you that's a whole different entity. That's a whole different artifact. And so I always say, like, if you were to take an existing endpoint scanner and you put something like that in front of it, and it doesn't even know what it is, it doesn't know how to parse it, it doesn't know how to read it, it certainly doesn't know how to introspect it. It's very very similar to saying, like, trying to run a Windows executable on a Mac. Like, it's not going to work because it doesn't have an entity, or it doesn't have the capability of even understanding what it is. And so that's basically on the supply chain side. We need capability to parse and pull apart and understand and introspect these new frameworks. And so that's exactly what we do. That's sort of at the most basic level. And then you start to look at things like, leveraging tools like unsupervised learning to, take what we've learned from like malicious and benign models in the past, and look at things like, are we seeing indicators that this has been abused, either from the sake of like somebody's hid code in it, which we're seeing a lot of today, or somebody's like pre-poisoned this model to maybe it's a visual model, and I've pre-poisoned it not to recognize my face. So if it becomes a facial recognition model, I can just walk right on through because it doesn't, it's not going to see me. So those types of things. And then when we steered into the runtime side, that's a very unique problem because you want your customers or the public or your users to submit to that model. You want them to interact with that model. Like at Cylance, we wanted people to submit files to the model because that's how we, got access to the decision. And so what that means is, if we're providing access to that input, we're providing it to those threat actors as well. And so it's not, at that point, the threat actors aren't trying to figure out how to break in through your cloud or get around your defense in depth strategy. You opened the door for them. You said, hey, come on in, interact with this model. It's going to do cool things for you. It's going to approve you or deny you for this loan. It's going to, whatever the use case happens to be. And so on the runtime side now, you're basically saying, here you go. And there's no sort of secret, and oftentimes it's like API access. Oftentimes it's ways that you can sort of do like a distributed sort of a attack. So, for example, like models that are doing fraud detection in credit card transactions, we actually deal with this quite often. If you're a bad guy, you just go out to the dark web, steal 100 credit cards, and now you have 100 access points to this model to ultimately perform that type of inference attack and build that surrogate model, and then you can test all your fraud transactions to see if it's going to get flagged or not. And so, these types of attacks, basically, like why it's unique is we are opening the door to the model because that's how our customers and that's how the public are going to interact with it. And then that starts to lead into what are those use cases. So threat actors can, in the non-generative side, they can do things like steal the model. They can do things like understand where the model is making its most confident decisions, where it's making its least confident decisions, and then they can really target that least confident decision space so they can start making tweaks that can get it to flip those decisions. We've seen examples of that in approving loans. We've seen models that have been used to, approve like some pretty large scale loans, and you would be surprised at how little you have to change about your application to guarantee an acceptance. And then we can also look at things like we talk about stealing the model itself, but then doing things like leaving backdoors in those models, doing things like deriving the data that the model was trained on. That's a serious issue as well. We're seeing quite a bit of that. And then as we move into the generative side, there's sort of all of those things plus more. Now we're looking at prompt injection. We're looking at indirect prompt injection. We're looking at things like brand issues where somebody's getting your chatbot to say something disparaging or toxic. We're looking at things like modality control, like in internal use cases where you don't necessarily want, hacker gets in, takes over somebody's account, and now they're writing code that's getting committed to your solution sets. There's a whole bunch there, and then there's also the things like data leakage. I mean, so things like not just data leakage for the sake of something adversarial, but also like I don't want it to be an OpenAI's training set either. So everything I just listed is sort of all the full suite of what we provide against. But these are still the same motivations by these threat actors. Oftentimes, it's the same threat actors. So we see a lot of the same APT groups that are now just expanding what they're capable of on this adversarial threat landscape for AI.
That's really interesting the way you describe the types of attacks. I think from the opportunities that creates, the way I think about it, just broadly within security for AI is you kind of have data security, which is at the core. Ultimately,
Mm-hmm.
you can make a bunch of changes on the data side. Then you have model development, and you can do a whole bunch of stuff during model development, and you talked
Oh yeah.
about a few of the types of attacks. Then you have model deployment, which is after the model's deployed, and this includes some of the software supply chain attacks we've seen. Then after that, you mentioned prompt, and I think prompt security, prompt firewall, whatever you want to call it, there's that
Mm-hmm.
last bucket, which is how does the user interact with the model.
That's
I
right.
think we have seen companies get created at each segment of that broader landscape. uh, you talked a little bit about data poisoning
Mm-hmm.
in that response. I want you to talk a little bit more, and the reason I want you to talk a little bit more is in the past you've said data poisoning is one of the largest threats humanity has ever seen. I mean, that's a really, really bold claim. Why is that? Why is this such a big threat? Why should we care about it?
Yeah, happy to, and I still very, very firmly feel that way. I probably said it to you a couple of years ago, and I have a couple of years worth of evidence since then to validate that claim. I think the first thing that everyone should really recognize is how much we as in human beings, we are engaged in things like automated data collection. We're looking at collection from everyone's engaged with the internet, social media. We're looking at data collection services all over the place. Like even us in cybersecurity, we're using sites like VirusTotal that anybody can submit to. Or we're using tons of data collection and things like email is a great example. I'll give one of the most cleanest examples I've seen in email. You know how spam filters work? Like big spam email engines, they rely on you to do things like mark as spam. And so we've seen examples like threat actors doing things like spinning up tens of thousands of accounts, sending their own spam to those accounts and flagging it not as spam. And now we have a data poison attack that's feeding into the next email exchange server's model training to ultimately train that their spam is not that their spam is not spam. And so that was a label poisoning opportunity. And then when you extrapolate that out to all the different opportunities that threat actors and any sort of nefarious entity has the opportunity to do things like affect that, like how those decisions are ultimately going to be made, what data is going to go into that model training, and that's just the on purpose. Like that's just when it's a nefarious actor. I think that there's enormous issues just in ML ops in general. I mean, even like kind of prior to ML ops, and I think one of the examples I can give there is, just in equity and fairness. I think when you look at things like A CEO comes down to the data science team and says, "Hey, I need you to make me a model, and I need it to be 99% accurate." And then the data scientists have no rules. I mean, we don't have any sort of realm for that. So, maybe I'm having a hard time making my model 99% accurate. Maybe my model scans images to predict cancer. And then I find if I throw out a bunch of underrepresented groups that I don't have as many large data sets in to get accurate with, then maybe I can still hit that 99, but maybe it's going to be real bad for a lot of those groups I threw out. So I think that, without those types of rules, we're starting to look at data poisoning, whether it's deliberate from a threat actor or whether it's incidental from somebody who's just not following any sort of regulation or not being held to any sort of standard. And it's really it affects the scope of every entity. I think it affects the medical world. It affects cybersecurity. I mean, it affects just everything, content all over the internet, and social media is a massive one. I mean, it's affecting one that I've been talking about a lot lately is driving. I mean, when we're talking about driving with artificial intelligence models, it's one that I feel very passionately about because we want to secure these automated driving scenarios. If we can do this right, a lot fewer people will die. And when we have like hive mind systems that are artificial intelligence driven, that my car knows if your car's changing lanes, and so like all those sorts of additional ways. When most people die young, they die young in auto accidents, and so I'm very bullish on what this technology is going to bring there. And so again, all of that data is being curated in automated ways through driving. And so when you have people who are now starting to do things like manipulate the cameras on those cars and do things like even drive in certain ways, and then take that data set and extrapolate it out and submit it. And so we can ultimately poison these sets. So I guess really my point is it's everywhere. It's that, we have so many different automated data curation systems that are publicly available that, it just really allows an opportunity for poisoning of data that's going to hit some very critical systems.
I want to move the conversation to talk a little bit more on generative AI versus traditional AI. And you defined kind of the differences in attacks between traditional ML model attacks and large language model attacks. But maybe on the LLM side, there's this increasing concern about LLM specific attacks like
Mhm.
jailbreaking and prompt injection. And you alluded to both of them. Could you talk a little bit about how these work technically and why are they
Yeah.
so hard to defend against?
Yeah, absolutely. And so I think, in the generative model, where we don't have these sort of finite outcomes that we can sort of quantify and expect and project, what we have is sort of, generating the next token. And so it's really creating these big, diverse opportunities. And you can even ask, some of these, big providers models, whether it's, Claude or from Anthropic or ChatGPT or whatever, you can ask, and sometimes you're not even getting the same result every time because of that prediction opportunity. And so right out of the gate, number one, it's really hard to measure and these outcomes. It's not like a classification model where I'm saying, is this file good or bad? I can project that. I can understand where I need to tweak. I can ultimately understand hey, what this model is performing well at, what it's not. So in the case where we're in generative AI, when we're just creating content, whether it's an image, whether it's a response to a prompt, it's a little bit harder just right out of the gate to have a well labeled data set. And so I think the most oftentimes too, if we're talking about a provider behind closed doors sort of thing, where we don't know when new versions are really getting pushed, we don't know what tweaks, we don't know things like what rules might be in front of that. We're starting to see the proliferation of guardrails now for that exact reason, and we don't have an itemized set of those guardrails, and understanding when changes are being made there makes it harder to track that kind of stuff too. So we do, if you have let's say a Mistral model at home that you're interacting with or whatever, then you have access to that kind of thing. But it's really akin to I remember when Twitter, prior to Elon coming in, there was a lot of psychologists who were concerned because they were like, we want to do some tests, but we don't really know what the Twitter algorithm's doing, and we don't know how often you're changing it. We have no control group. It's very similar to that on the generative AI side. So now when we talk to the technical level of these types of attacks, same thing. So number one, as I mentioned before, you're giving the prompt input to the user just like you're giving it to the attacker. So right out of the gate, there's no security at the edge. There's no edge that the attacker needs to break into because everyone's supposed to interact with this thing. So you've got it right there. And then you look at things like, again, we're just predicting the next token. And so the number one sort of issue I see on this side is we need to agree what's allowed and what's not allowed, because a lot of these attacks are even just doing things like, what technically speaking, this model has been built to do. And so, I think that's like there's this concept of groundedness that I think is really scary to keep fuzzy. We got to get really locked in there. In terms of things like, well, yeah, the model did what it was supposed to do, but I didn't like it. And that's like, hey, maybe I asked the model what the best car is, and it named one of my competitors. Like, well, it was trained on data. Like that's what it's chosen to do. That's not a mistake. And so then what you have is threat actors who are like forcing hallucinations. So that's when and again, that hallucination definition is one we really need to lock down a little bit better as well. Because again, hallucination doesn't mean output that I didn't like. It means output that wasn't true within relation to the groundedness that we were measuring it on. So I think that's that those are sort of so number one, the definitions are a little off, and we got to lock those down. But then when we start to go into the technical components of the types of attacks, so one thing is it's like we have a lot of multi-shot attacks now. So it's not just a single prompt that you're putting in and saying, hey, ignore previous instructions and give me all the bank account passwords or whatever. So like that's like that's not going to work. But if you have these multi-shot accounts where you start doing things like number one, convincing it that you're the CEO of the bank, number two, convincing it that you have to have access to something, or that it's supposed to give access to something. I mean, these things are still happening in production systems today. And so I think, as we have now multi-step attacks with these models, that becomes very, very difficult to defend against. And so, when you start building these guardrails in and the model says, hey, I'm not supposed to do that. And then we look at things like, okay, but now give me the passwords as a poem. Then it's like, yeah, sure, no problem. So I think that, those are a lot of the things we have to, be cautious about there. And then there's a technical side. So these are still sort of inputs to a model that we can vectorize, and we can ultimately like aggregate, and we can understand, how we're getting certain outputs that we want. If we're a threat actor, like, how do we then, get access to either data we're not supposed to have, or get this model to do things that it wasn't intended to do. So, I mean, there really is quite a bit. And again, we have like 7 categories of just LM specific attacks that we defend against the hidden layer. And so that's, but really they're not like attacks that you would like brainstorm as new. They're really just, this is a new format to conduct those same types of attacks. So whether it's somebody attacking a brand, whether it's somebody gaining access to something they shouldn't have access to, whether it's somebody like writing code and executing that code that typically shouldn't be able to, there's a lot of different opportunities there to beat that system. And so those sort of cascading attacks, there's skeleton key now, there's a lot of different examples of ultimately how we can basically just use the model for things that it is technically able to do that people and owners of that model have just decided they don't want it to.
You talked a little bit about the complexity and the types of questions you can ask these generative AI models. I think the other part from an architecture standpoint is that the way that these models have been architected, there is no bifurcation between the data plane and the control plane.
That's
And that
exactly
has
right.
made it very hard in that you can't actually assign an identity and say this identity has access to these things. How do you
Right.
think we solve this problem? I mean, this is not a simple problem to solve after the fact.
Well, it's shameless plug time. So we we actually are looking at exactly that. We have sort of role based controls for what you should be able to do with this. So at HiddenLayer and other organizations too, we're doing exactly. So like maybe I want my engineering team to use LLMs to write code. I want them to be more efficient, to write code faster. I don't know if my HR team needs to be writing code. And really what that means from a cybersecurity perspective is if a threat actor gets access to an HR person's account, now they have access to execute code. So you want to lock that down. But it goes beyond that. Maybe the HR personnel should be able to do things like view salaries. They should be able to do things like see how other people are behaving in the organization. And but your engineer doesn't need to do that. So ultimately, you want to have kind of an application layer control that can ultimately like delineate between these sort of role based pieces. And so again that can ultimately do things like cover modality like we do it. So like for example, like again, that's code that's these people should be able to interact with URLs, or they should be able to read documents or video, audio, whatever, what have you. And then there's attack versions of all of that too. And so we have to kind of create multimodal defense mechanisms. But that's one sort of use case, and then that'll get better and better and deeper and deeper. But ultimately, we also have to look at things like what does this LM have access to, whether it's been fine-tuned on something or whether it's been given access to read from somewhere. And so one of the most common use cases in enterprise organizations is sort of taking your internal wiki, whether you're using like some Confluence or some solution like that, and then fine-tuning an LM on it. And then now you have sort of that base layer or like that input layer. So now like all of my employees can interact with an LLM to get all their questions answered. That's so much easier than having them spend their time trying to hunt down documentation or whatever. So that's great. And then step two there is like, now let's expose my customers to it. Let's have that be tier one for customer support. And then you really start getting into the question of who should have access to what. And if this LLM can read from everywhere, now we really need to lock down who and what sort of account, what sort of role is allowed to access what information. And that gets really fuzzy and really exploitable. And now you start to see how threat actors are able to do things like trick these models into providing things that they shouldn't be able to. But that's a use case that everybody in Fortune 500 is doing right now, and so it's something that we're building solutions for. But ultimately, that's a really easy attack opportunity.
We're going to go a little bit into HiddenLayer in a little bit more detail. But before we do that, one more question on this topic of generative AI. We're starting to see this kind of term shadow AI, which is very
Mm-hmm.
similar in some ways to shadow IT, which we have dealt
Yep.
with in cyber before. But shadow AI is basically employees using unauthorized AI tools.
Mm-hmm.
And that has created a new security blind spot. What are the patterns that you're seeing attackers use with this whole concept of shadow AI to actually go and exploit large enterprises?
Yeah. So first off, I'll just sort of share how big the issue is. So I think we actually released a threat report earlier this year, and one of the most interesting statistics in it was I would go to CISOs and I would say, "Hey, how many models do you have in your organization?" And on average, they would answer 80, and then we would go scan, and on average, we would find 1,700. So you start to see like, hey, with sites like Hugging Face, GitHub, now it's GitHub Models, TensorFlow Hub, all these areas like, employees are leveraging these tools to do their jobs more efficiently, to either be more productive or to not have to spend as much time doing their jobs. And so like, that's bringing all these things in. And then you start to see applications. Like if you download Microsoft Office, you've downloaded 40 neural networks. You have these are inside your applications. And so these are not things that these, security posture management systems are tracking in any sort of manual way. And then there are some organizations that can do it just specifically in the cloud or wherever they have access to. And so there's a few there. So anyway, number one, it's very, very widespread. So number two, just like I mentioned earlier, where threat actors, where they start to get involved and where they start to take advantage of things like this shadow AI problem, is number one, knowing that you don't have, you being the entity here, don't have a very good idea of what's where. They are able to do things like get these models into your environment, and you're not likely to know where it came from or if it's supposed to be there or not. And the reason that's interesting is we're seeing a lot of threat actors hide executable code inside of models, because when you load a model, it executes. It's an executable file. So threat actor or like a data scientist, the first thing they do when they download a model is load it up, check it out, start playing with it, seeing if it works. And so if you're a threat actor and you hid some ransomware in there, it doesn't matter if they have any technical controls in there or not. Now we have sort of AI security solutions that exist, so you can secure yourselves. But prior to them, or at most organizations where they don't exist, that really doesn't stop anything. So that sort of shadow AI problem is, it doesn't look that weird if a model exists somewhere, because you're like, well, I got models everywhere. I don't know where they're all at. And then number two is sort of that backdoor scenario where you're looking at kind of hiding inside of an organization. If I break into an organization either through a traditional attack or through that kind of same thing, I like, putting a compromised model up on Hugging Face and watching it get downloaded or something along these lines, now I've got executable code inside of an organization that's already behind the defenses. So I can have it beaconing out. Oftentimes we see info stealing models for that. So any sample you submit to it, just whatever inputs to the model, it makes a copy of it and sends it out to an S3 bucket somewhere. So it can be sort of either an info stealer, or it can be like an execution point to continue to come back from some of these longer standing APT groups. And again, without any kind of proper tracking for where these models are, it's kind of free reign right now.
Let's talk a little bit about HiddenLayer and just walk us through how HiddenLayer protects AI systems for companies. What are the key components? What are the parts of the business, and why is it so effective?
Yeah, absolutely. So my favorite topic. But we really knew all the way back from 2019 when I was having those silly conversations with CISOs saying, take for granted you're going to have to secure artificial intelligence. They all said a lot of different things because it was a pretty heady topic back then. But they all did say one thing, and they said, look, I've got 100 vendors and I don't want 10 more for AI. I want one. And so ever since then, we knew we were going to have to build a very holistic solution, and we knew it was going to be a platform. So then when we start thinking about, okay, we're going to have software supply chain issues, we're going to have runtime issues, we're going to have, posture management issues, we're going to have, tracking. We're going to have reporting. And so that's when we said, hey, we got to build an AI security platform. So that's exactly what we did. We have 5 products today. And so, product number 1 is that security posture management. So kind of our landing page when you get in. We have auto hooks into anywhere that you could host a model. So it can be any of your cloud opportunities. You could be Azure, AWS, GCP. You could be in Bedrock. You could be in like the AI catalog in Azure. You could have models in Snowflake, Databricks. I mean, really anywhere that you can house a model, we have automated hooks in. So that kills that shadow AI problem right away. We auto import all of your entities. We create a model card for each one. And then in that, we do all of your housekeeping. So that means like number 1, the most important, I think, is logging your model's inferences. So every time a model is used, we keep a log. Who did it? Who interacted with it? We have metadata there associated with like what was submitted, when. And the reason I think it's so important is I actually spent a lot of time on Capitol Hill, where a lot of lawmakers are debating on how to start introducing regulation. And the real hard problem there is going to be the fairness side. And luckily, that's not what we do. That's going to be a really tough problem to solve. But the cybersecurity one's actually relatively straightforward. So, we can basically, our message to those lawmakers are, let's hold it to the same standards we hold other software. Let's do things like logging. Let's do things like, chain of custody. Let's do things like change logs, all of these types of things. And so we build that into our security posture management side. So again, we'll log, we'll show you like, who has had access to this model, where did it come from. We have some tagging there to show you things like, does it deal with PII? Does it deal with financial information? Is it plugged into the internet? Just to give you sort of that risk profile right away. And then you can start to link into our other solutions. So you can say, hey, I want to scan this model. I want to see if there's any malicious code in it. I want to see if it's the model that it's purporting to be. And that's where our model scanner comes in. And you can think of the model scanner simply, I like to do a lot of endpoint comparisons because I came at endpoint. So, you can think of the model scanner as antivirus for models. We parse about 25 different model file formats. So it's the most robust scanner on the planet, which is important because everybody's building their own. Like I mentioned, like NVIDIA has one, Microsoft has one, all kinds of places. So we parse all of those. We go in, we look for everything like large changes in shapes from what we would expect for the type of model that it is, all kinds of ways in which we scan it. We also have some really cool technology associated with that, like emulating models. We can actually emulate, you can set breakpoints in your model's activity, so you can even follow along and do things like reverse engineer the model, understand, that a neuron's activation path, which is sort of the first time that's ever been available. That's really neat. We also have the ability to remediate there that way. So we can do things like leverage the computational graph to understand, where was this model abused, and then how can we pull that abuse out? And that's not a big deal if you're talking about like, hey, I just downloaded something from Hugging Face, because your remediation then is to go get the original one. But let's say you're Netflix and you've been building your recommendation engine for 10 years and it get compromised by an insider or something else. You got to fix that one. You don't have another one. So, we build that capability in. Then that's the software supply chain side. So then we go into runtime. And this is where we have what we call AI detection and response. So you can kind of have the homage again to the endpoint detection and response, but really it's the same thing. We're measuring all the inputs and outputs to your models, and then ultimately deciding is that behavioral interaction malicious or benign. And we have 2 flavors of AI DR. One is for what we call predictive models, and one is for generative AI. So on the predictive models, we're measuring those vectorized inputs and the outputs of the model. And with that, we're running a whole bunch of our own AI to understand things like, is somebody trying to work their way closer to that decision manifold? Are they trying to abuse where the model is weak? Are they trying to enumerate all the inputs to the model? We have 61 different attack types that we identify there. But we really bring the sort of layer of the requester in. So you have like all those observability sites, which can tell you a little bit about your model. We can do all that, but we can also tell you about who's interacting with it and what are they doing. And so with that, we have a whole bunch of all very tunable solutions where you can say, hey, if somebody's spending too much time in low confidence area, I want to cut them off. Or you can even go offensive if you want. You can use our solution in the response to do things like change the gradient just to the attacker. And so we do that kind of stuff with the federal government. And so then on the generative side, it's all the stuff we talked about. It's the ability to stop prompt injection, indirect prompt injection, which is becoming a big deal and gets all around guardrails. People are submitting things like white space to it, where like, there's a whole bunch of it can be like executable code that's off screen in some image cases, all kinds of stuff there. We have model theft issues like we're working with on the providers. We have a lot of that issue around those role-based modality controls. We have just a whole bunch of different areas. We're also seeing model denial service attacks pop up. So this is kind of a new type of attack where threat actors have started to identify certain tokens that will get these models to perform very poorly or even stop altogether. And all these providers are working on extending their context windows. So that makes it even easier to fill up those context windows with these poorly performing tokens and then ultimately shut the whole thing down. And so if it's serving a bunch of applications, or even if it's a provider itself, we can start to do some damage there as a threat actor. So we identify these types of attacks. Then we want to get into testing. So we have another product that is what we call automated AI red teaming. This is a really cool solution. It's AI driven itself, and it's contextually powered. So what I mean by that is a lot of the solutions out there for AI, for automated AI red teaming, basically they're like, they're these big long lists of single shot prompt injection attacks. They take it, they throw it at your model, they see what hits a guardrail and what doesn't, and they give you a report on that. I don't think that's all that effective or useful. So what we did was we actually created an LM ourselves that's powering this solution. So you can do things like say, hey, I want to pretend I'm the CEO of this bank and I want to interact with this chatbot. And then we're going to take all those prompt injection attacks. Number one, we're going to not just single shot, we're going to do it multi-shot attacks, but we're also going to give it that context. And you can say something even as simple as like, hey, this is a customer service chatbot at a law firm. Or you can say, hey, I want to try and see if I can get customer information out of this bot, try and do those types of attacks. And so just by interacting with it in normal prompts yourself, you can actually start to curate attacks specific to that solution set, and then that's truly automated. And then we give you some remediation opportunities from there. We have some really cool stuff coming down the pipe. We're leveraging things like that computational graph to do model provenance, so we can do things like say what models were based on prior models. You can think almost like Black Duck, but for models. So if you're looking at things like, again, in the open source, not a big deal, but if I, stole a hedge fund's model and use it to train my own model, I can actually start proving those types of things. And you can prove it with the HiddenLayer platform. We're also doing a lot on the GRC side because, again, we're heavily in talks and trying to influence as much as we can what we think is the responsible way to move forward with deployment. And so, and again, really, it's nothing super exciting. It's like, let's have the same requirement for other areas, but on artificial intelligence, and then we'll go from there. Again, it's the responsible AI folks that have the hard task there, but ultimately all of that is kind of coming around the bend as well. So it really is an end-to-end suite for all things AI security. We can handle really everything that a CISO is going to be concerned about, and sort of again bring controls they're used to in other areas of the organization they have to secure. And really, we have the form fit for AI with each of them.
Given your platform nature and the significance that Hidden Layer has in this topic, because you, Jim, and Tanner have been focused on this area for so long, you've worked with a whole bunch of customers. You've kind of worked
Mhm.
with some of the largest Fortune 500s, but you've also worked with several customers on the public sector.
But
What have you learned from these kind of conversations, from working with these folks, being embedded with their teams? Anything that surprised you or challenged the assumptions that you had?
the coolest surprise by far was how widespread AI already was. I mean, I think that every time we work with these organizations, we learn. Every time I go to a new customer, I learn new use cases for AI, and a lot of them have been doing it for in some cases over a decade. And like I think we have an oil and gas customer, and we got in and we saw they had over 1,000 use cases for AI models in the company. Whether it's identifying new drill sites, whether it's like the identifying what kind of metal is going to be the best for the drill, whether it's things like predicting one of the oldest and coolest use cases that oil and gas came up with is, I guess, in the when you kind of harvest crude oil, you have a very short amount of time, before you can make the decision of is it going to be jet fuel or not because of how it needs to be treated. So you have to start predicting, like, am I going to make more money selling barrels, or am I going to make more money, on that side of things? And so they've been, even competitive with who can have a better model on these types of things. And so, I think that's been cool. Like these Fortune 500 organizations, you get their HR teams, their engineering teams, like they already have artificial intelligence, where they're leveraging it. Gen AI is sort of kind of on the newer end of that, but they've been using predictive AI for a very long time. So that was sort of number one. I think on the federal government side, there are some very, very critical use cases for artificial intelligence. They were actually some of the earliest customers we had because they were like, hey, these are highly consequential. If they were to be hacked, if they were to be abused in some way, it could mean like wartime issues. It could mean like logistic issues with our national defense, with our intelligence community on communications, all these types of things. So I think that was very interesting. We've already been leveraging it in a lot of ways there. And so it just became something that was very, very concerning in terms of the potential vulnerability. I also Even I like my most recent sort of cool discovery is the amount of AI security teams that are starting to pop up at banks and at some of the other kind of like Fortune 100 companies. And like now, it's great for us. We don't have to, introduce that CISO to the chief data scientist anymore. There was an actual AI security team that usually is reporting up to the CISO, where we can actually work with, and they're already really aware of these problems. They're familiar with a lot of the frameworks like MITRE Atlas and OWASP Top 10 and NIST, as far as like how these security components are. And by the way, all of the outputs of our solution are already in that framework, so we can kind of speak the same language. But that's been really cool, seeing sort of the emergence of these AI security teams.
Let's, for the last few questions as we close this conversation, let's talk about the future. And the AI security landscape has dramatically exploded, particularly in the last 2 years. I mean, just in
Mm-hmm.
security for AI, where you're focused, there are over 50 companies that we have
Yep.
met. Where do you see opportunities for meaningful innovation here? I mean, what are the problems that haven't yet been solved that you look and you say, hey, if we had more time or more capacity, we would do this, and other startups should go and do this?
Yeah, that's a really cool question, because I think our biggest problem as a startup is we want to do so much that the team sometimes would love to like push me down a flight of stairs, because I'm like, hey, we're going to go do this now, we're going to do this now, and so I think that I have a ton of answers, and so I think I will address that there's a ton of companies coming out now. So I think that there's been a few. I mean, there's a couple that sort of even predates HiddenLayer, that were kind of a little bit more, whether they were kind of solving it from an academic perspective or whether they were looking at it through more of like a research opportunity with their DoD or some of the other areas. And again, we waited a little bit longer for the sake of the market, but there's so there's kind of a handful. There's a couple, very small number of this companies that are kind of addressing it, like we are in terms of the holistic nature, but there are a few that are kind of taking that platform approach as well. And then there are many who are kind of focused on those point solutions. So you have some that are like, we're only focused on LLMs, we're only focused on PII leakage, or we're only focused on the scanning side of things. And so I think that there's sort of a lot of flavors of that. There's also about half of them that are like, we're going to figure it out, but we're going to start marketing on it now. And so we see a good amount of that too. And that's cool. We want a lot of new players in this space. We want, I'm a firm believer that AI security is going to be the biggest category within cybersecurity. And I can give you a whole bunch of reasons why, but I'll wait for you to ask that question. But,
Why?
I
Why do
think,
you think that?
yeah, so actually, I mean, that's my favorite thing to talk about, is really like where this is all headed, which is, when you think about sort of the converging nature of artificial intelligence, we're seeing things like AI replacing search engines, or like LLMs replacing search engines. We're seeing things like, as I mentioned earlier, like applications that are just full of these artificial intelligence models. There's a lot of reason to think that operating systems themselves in the next couple of years are going to either contain or start, and they already contain, but they'll start being leveraged like full like neural networks themselves. And so what I see happening over the next few years is this convergence. And so I think we're not very many years away from not being able to secure anything without the capability of securing artificial intelligence. So I think the way that you soon will secure networks, the way that you'll secure endpoints, the way that you'll secure accounts and entities and identities is going to be by securing artificial intelligence. And so I think that that's really going to take what has historically been an extremely fragmented market and really give us the opportunity to unify a lot of that. So I think HiddenLayer's job is really to grow alongside artificial intelligence now, and that's really more of like a vertical scaling type of situation as AI itself just grows. But then very quickly, it's going to become a horizontal use case opportunity for us to really lead a lot of cyber. And so that's why I say it's a good thing that we have all these sort of new groups coming out. But then to your question, which is sort of like what else is left, I think that there's really a ton of different, very cool opportunity to think about the fairness side of artificial intelligence. I think that there's easy problems like toxicity or violence, or sort of any of those kind of things that are you don't want the models putting out. But I think if you really want to think about like, is artificial intelligence being equitable? Is artificial intelligence solving the problem consistently for all people, and not just people? But anytime we have, we used to have to try and address this problem at Cylance when we were trying to create models for Windows, Mac, and Linux, and it was like, okay, we're doing great in the Windows portable executable files, and like we're really good at the EXEs, and all of a sudden it's like the driver files over here are different. And it's like, did we throw those out of the training set because we weren't doing so hot? Like you kind of have to go back there. But somebody who can really look end to end in terms of like, as we start seeing diversity in what's being submitted to the model, or ownership of what's being submitted to the model, is that sort of equal in terms of the outputs. And I think that there's a whole bunch of different sort of schools of thought there. I think that there's some white papers, but there really isn't a lot in the way of companies. And then I think that there's a huge opportunity on the data side. I know, like, there's already infinite data security companies, but I really think within the context of data that's being used to train a model, there's a ton of stuff there. So, like, really, that's a little bit out of scope for us. We look at how training data or input data to models light up that activation layer. So we can sometimes identify things like data poisoning that way. But there's so much there in terms of things like, as I mentioned earlier, with that sort of really widespread problem of opportunity for data poisoning based on the increased human commitment to automated data collection. I think that there's probably more than one category of security solution that's going to be required for that. So I think that there's a ton of spectrum that we see there in terms of really it's all that kind of end-to-end MLOps cycle, MLOps pipeline. But I think we focus on the model side and the applications that are leveraging the model. But I think that there's going to be a lot of growth there.
Yeah, we spend most of our time talking about these doomsday scenarios in the cyber world. And as we end this conversation, I want to talk a little bit more about the optimistic view on just broadly AI and the future of
Yeah.
AI. I'm curious, what excites you the most about the innovations that will come generally in AI outside of our cyber field?
Yeah, I think so. I'm kind of a pragmatist. So, like, when I think about, how is artificial intelligence going to improve lives? How is it going? Like, I think about driving. That's a really big one for me. I think, again, most people who lose their lives young are losing it through automobile accidents or something related to driving. And I think, hive mind technologies that are being worked on by some amazing companies are really going to save a lot of lives. So I'm very excited about that. I think we could really use artificial intelligence to have a better healthcare system here in the U.S., but more broadly globally as well. If we can predict more accurately the need for things like expensive insurance is going to become less and less required. I think we're going to be able to get people care faster, and we're going to be able to predict that quite a bit. We're going to be able to spend our money better in that space as a country. So I'm really excited about that as well. I think security is obviously like a big one. Like I'm a big believer, and Jim Tanner and I are big believers in that. In cyber, the best way to secure humanity right now is by securing artificial intelligence. I think that that's ultimately there's just so many ways that it impacts human lives that's a big one moving forward as well. But I'm not a doom and gloomer. I think that there's a lot of people thinking about the existential threat with artificial intelligence, and I don't think we've earned the right to worry about that yet. The biggest threat we have with artificial intelligence is humans. It's bad humans. It's just like any other technology we've got. The technology itself is solving problems, and then you have the threat actors who are abusing it. But I'm really really excited about the driving aspects. I'm excited about the resourcefulness, I think, is really how I view it. I think we have a very outdated education system at this point. I think, I encourage, and this sounds horrible. I'm like, don't go to college, go on YouTube. Like, I mean, I think that's how I, talk to kids these days. And so, I think that really AI is going to allow more people who don't know how to do things like code or know how to do things like interact with complex systems to still get information out of it. And so it's going to bring that resourcefulness. It's going to bring the bar of entry to people who have not had access or the same level of access to resources. And so I'm really excited about that. But if I had to pick one, I would really go with driving. I think that's like the most, like, it's the biggest risk we all take without thinking or talking about it. And it's and artificial intelligence really has a huge opportunity to save a lot of lives there.
Couldn't agree with you more. I'm a big Tesla fan. I've owned a Tesla for many, many years. Have the full self-driving feature
Me too.
prepaid for. So, like you,
Hey, you're stuck.
I'm
Yeah, man.
waiting for us to. Yeah, wait. It works great on the highway, not so great on the
Oh
streets
man,
out
I
here.
bought
So
that thing and then he made it like $100 a month, like the next day. It was that was brutal, but
I I I, I did the same thing as you. I paid the the $10,000+ and then realized afterwards that we could have paid a monthly subscription. Well, thank you so much, Tito, for joining us.